some extra practice with our inverses. We're starting with x cubed minus 8. Cubics are nice to take an inverse of because they're one-to-one without any domain restriction. So I'm going to go ahead and start just by graphing this guy. X cubed minus 8 is our x cubed parent function, which looks like that-ish. And it's moved down 8 units. So I'm going to start down here at negative 8, over 1, up 1, over 2, up 8. It would be over 3, up 27, and that is not going to fit on our graph. So we do want to make sure we're always graphing every point that fits on our graph as we're practicing transformation rules. All right. Now, we find our inverse. I guess we could go ahead and write out there our domain and range. So for f of x, domain is going to be all reals, and so is range. Okay, let's find the inverse then, for real. So I'm going to switch f of x to y. Switch x and y. And solve for y. So a lot of students will just eyeball this and then make a lot of mistakes, like little sign mistakes mess up your whole entire problem. So I really encourage you, write out the steps, even if it feels like you're in Algebra 1, that's okay. Algebra 1 is important stuff. Take the cube roots and do the cubes. And we denote the inverse using that f to the negative 1 of x. So this is our x cubed function. It looks like this. The more times you sketch the parent functions, the more repetition, the better. You want these in your brain forever. That plus 8 is left 8 units. So my cubic is going to start over here. Up 1, right 1. Down 1, left 1. And then go up 2, right 8. And that, you should be feeling good about this inverse right now because you have this guy in your original function that was at 2, 0, and now you have this guy that's at 0, 2. Just spot checking 1 or 2 places to make sure that x and y are really switching. It will help you a lot, I think. Okay, so here's our function. That was a decent graph for me. You guys know already at this point that I'm not a prolific artist, but those cross pretty close to that line, y equals x. Our domain and range here for our inverse are the same as for our original function. Our cubic also has domain and range of negative infinity to infinity. All right, the last thing we're doing with these is show that these are inverses using composition. This is a great place to practice function composition. So I'm going to do, and I feel like function composition of these is relative, like you just have to be really neat and really precise. So my inverse is cube root of x plus 8. And I'm plugging that into my original equation, which was x cubed minus 8. So I really like doing that. Just write it out with that set of parentheses instead of your x, and then put your new x in. And then order of operations carefully. Here, our cubics have to cancel first. Our cube root and our cubic cancel first. And then we cancel those guys. And now we're going to go the other direction. Remember, to prove this, using composition, you have to go both directions. Both directions have to equal x. So was x cubed minus 8. And we're plugging that into our cube root of x plus 8. So here, I'm going to cancel my 8's first. And then our cubic and our cube cancel each other. Lovely. Extra practice with inverse.